Introduction to Software Testing. Welcome to this course on software testing. Topics covered in this course are evolution of software engineering, need of testing, goal of testing, understanding software testing. Evolution of software engineering. Software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. The term software engineering was first used at a 1968 NATO workshop in West Germany. It focused on the growing software crisis on factors like high development cost, poor reliability, lack of user acceptance, impossible to maintain. Surprising to learn that these issues were raised long back in 1968. Why is testing needed? Complexity of software makes it error prone. Untested or weakly tested software can cause losses in real life. For example, Disney's Lion King 1994-1995. The software did not work on the most common systems that the public had. Intel Pentium floating point division bug 1994. Intel took a charge of more than $400 million to cover the costs of replacing bad chips. NASA Mars Polar Lander 1999. Malfunction due to an unexpected setting of a single data bit. Patriot Missile Defense System 1991. A software bug caused the tracking system to be inaccurate after 14 hours of operation. Why is testing required? A defect in the software has a root cause, while the effect of defect is seen as impact by different stakeholders. Testing is part of overall quality assurance. It covers the quality control aspect of ensuring quality. An anomaly in the software is called a bug or a defect. It may or may not lead to a failure during the usage of the software. Software testing may be required for the compliance or contractual or legal requirements. Testing is actually never completed. However, for practical reasons, it is stopped after considering the risk involved, time and budget constraint. Testing should provide sufficient information to the stakeholders for decision making regarding release of the software for the next development step or handover to customers. Goal of testing. Common objectives of testing. The goal of tester is to find bugs, to find them as early as possible and make sure they are fixed. Testing is a means to find bugs, provide confidence and information, even prevent defects. The change in attitude towards testing. There was a growing concern about the quality, but what was the attitude towards software testing? In 1950s machine languages, testing was nothing but debugging. In 1960s, compilers were developed. Testing a separate activity from debugging. In 1970s, software engineering concepts testing evolved as a technical discipline. Over the last 2 decades, the attitude towards software testing underwent a major positive change, and there has been an increasing focus on better, faster, and cost-effective software. Understanding software testing. Testing is the process of executing a program with the intent of finding errors. Quality control (QC) is testing the software or product for its intended behavior. Quality assurance (QA) Testing the processes involved in developing and testing the software or product. Verification is to establish the truth of correspondence between a software product and its specification. Validation is to establish the fitness or worth of a software product for its operational mission. Verification, are we building the product right? Validation, are we building the right product? Who makes a good tester? A tester's mindset must have the below mentioned attributes. Keen observation. A tester just not concerned only about the test inputs and the expected output. He should have a keen observation on the functioning of the application under test. Only then he can think the test all possible test conditions that may not planned as part of test designing. Questioning skills. Another important aspect of a good tester should be the questioning skills. A tester should not restrict him or her to simply verify the functional specifications. Instead, start questioning the behavior of the application on every test condition. In that way, the application can be verified against the given functional specifications as well as provide some really better suggestions on the applicant's functionality. After all, an independent tester is more like the end user of the application, and it is more important to test whether the application is user friendly in all ways. Never give up. Sometimes, in the first run of the test execution, no defects might be encountered. But as a tester, he or she should develop the never give up attitude, try to find alternative way to unearth any possible defects. It would be very rare that the software developed is defect free. Interpersonal skills. The challenge of a tester does not end with finding the defect and reporting it. He or she has to maintain good relationship with the development team, and good interpersonal skills helps in early defect acknowledgement by the development team, which is essential for defect fixing and closure. Testing principles. Testing shows presence of defects, not its absence. Testing can show that defects are present but cannot prove that there are no defects. Testing reduces the probability of undiscovered defects remaining in the software, but even if no defects are found, it is not a proof of correctness. Exhaustive testing is impossible. Testing everything, all combinations of inputs and preconditions, is not feasible except for trivial cases. Instead of exhaustive testing, risk analysis and priorities should be used to focus testing efforts. Early testing. Testing activities should start as early as possible and should be focused on defined objectives. Defect clustering. A small number of modules contain most of the defects discovered during pre-release testing or are responsible for the most operational failures. Pesticide paradox. If the same tests are repeated over and over again, eventually the same set of test cases will no longer find any new defects. To overcome these pesticide paradox, the test cases need to be regularly reviewed and revised. Testing is context dependent. Testing is done differently in different contexts. For example, safety critical software is tested differently from an e-commerce site. Absence of errors fallacy. Finding and fixing defects does not help if the system built is unusable and does not fulfill the user's need.